we have oxidation and reduction half reactions that we're looking at today. And using that, we're going to use table 4a. You can use table 4a or 4b. I suggest you use 4a because that's the one that I'm explaining. So when you look at this table, you'll see at the top of the table that we have F2. And F2 plus 2 electrons will form 2F minus. Now we know that fluorine is a non-metal. If you look at your periodic table, you'll also see that it's the most electronegative element on the periodic table. Fluorine really wants to get rid of its status as an element with only 7 electrons in its outer orbital. So fluorine really wants to absorb an electron. If fluorine absorbs an electron, it has 8 electrons in its outermost orbital, it has a full orbital. So we know that fluorine really wants to absorb an electron. We can say that fluorine wants to go through reduction. And if you look at this table, it's called the table of standard reduction potentials because that is exactly what is listed here, the potential to go through reduction. You'll also see a value here of plus 2,87, which I'll talk about later on. What we see is that fluorine is indicated as F2. It is indicated as F2 because fluorine is a diatomic element, which means that when we have a molecule of fluorine, there will be 2 fluorine atoms combined. And that's why we see it will absorb 2 electrons to form 2F minus. If you go to the bottom of this table, you'll find lithium there. And if you read it with me, you'll see lithium is Li plus an electron forming Li. Now lithium is a metal and it's found in our periodic table in group 1, period 2. So this is a metal with 1 electron in its outermost orbital. What does it want to do? It wants to get rid of that 1 electron so that it doesn't have to carry around an orbital just for 1 electron. So lithium really wants to release an electron. And if you look at this reaction, if you read it from left to right, when lithium is lithium plus, which means when it has now released its electron, it will not want to absorb another electron. It will not want to go through reduction. And that's why it has a value of negative 3,05 in terms of its potential to go through reduction. It does not want to go through reduction. So how we use this table is as follows. Fluorine at the top wants to go through reduction. We can see that fluorine is the strongest oxidizing agent, while lithium at the bottom really doesn't want to go through reduction. It is therefore our weakest oxidizing agent. And you'll see on the left-hand side of your table that there's an arrow that points upwards to indicate the increasing oxidizing ability, which means our strongest oxidizing agents are listed at the top and our weakest oxidizing agents are listed at the bottom. And this is now, of course, on the left-hand side as we read from left to right. Now, how do we use this table? When we use this table, we will read reduction half reactions from left to right and oxidation half reactions from right to left. Which means that if you now look at lithium, we know that lithium, Li, wants to become Li plus with a positive charge, and it wants to release an electron. So we see that lithium will go through oxidation. We can also see that because lithium is at the bottom of our table, we know that lithium therefore is the strongest reducing agent. And that means that fluorine at the top will be the weakest reducing agent. If you look at the right-hand side of your table, you'll see an arrow that shows an increasing reducing ability as we move downwards. That means that lithium has a stronger reducing ability, is a stronger reducing agent than fluorine. Now, how do we use this table? When you look at this table, there are a few important things. The first thing is that you have to decide on the half reactions that you are going to use. And on the table, these half reactions have a double arrow indicating that they can go in 2 directions. But when you are using them, you have already chosen in which direction the reaction is going to take place, and then we just use half an arrow. So for example, we will see that this will be F2 plus 2 electrons forming 2F minus. So we just use an arrow pointing in one direction. Remember, your oxidation half reaction is going to be read from the right-hand side to the left-hand side, and your reduction half reactions will be read from the left-hand side to the right-hand side. Now, important also here, just two things. The substances that are on the right-hand side, which means this side of the double arrow, they are reducing agents and they are oxidized. Substances on the left-hand side of the double arrow are going to be your oxidizing agents and they are reduced. Now these values here, once again, if there is a positive value, we know that this substance will easily gain electrons. If there is a negative value, this substance will easily emit electrons or release electrons. And you need to know these basics to be able to understand this table.